Good morning, students. In the last class, our topic is 3 point starter. Basically, this is a 3 point starter. This is basically a 3 point starter. Ayush,
Yes, sir.
tell me the procedure, how it will work. I have explained in the previous class how the 3 point starter will work. So, why it is called? First, tell me why it is called 3 point. Ayush,
Sir, it is three lines, sir. L, Z, and
there is
A.
in this starter there are 3 point or say three terminal. Number one is L, number two F, and number three A. Though there is terminal of this starter, that's why this starter is called 3-point starter. So suppose a current flowing through this line and it goes to OLC. What is the full form of OLC? Khushbu, tell me what is the full form of
Over
OLC?
overload coil.
Overload coil. Good. Then the current goes to that lever. Then if we put that lever in position 1, what will happen? If we put the lever in position 1, what will happen? Going to Deepak, Deepak, tell me. Deepak, can you explain the procedure of 3-point starter, or say working procedure of 3-point starter? Can you explain it? Deepak, Ayush, tell me, if we put that lever in one position, what will happen?
तो सर वो चारों रेजिस्टेंस का वो रेजिस्टेंस आएगा टू minimize the current
That means the
initial
current is
currents.
divided in two paths, one flowing from there. This is basically field path, and another current is flowing through there. This is basically armature current, and it will flow through four resistance. And though we know that the initial, or say for DC motor, a initial high current will flow, so that's why we insert four resistance on armature path, by which we can reduce the armature current,
Armature current.
because at the time of starting there is no back EMF. At the time of starting, though speed is zero, though the value of speed is zero, so the value of back EMF is also zero. So at that time the value of IA is V by RA. So a initial high current will flow through the armature. That's why we have to insert it a series of resistance, say R1 plus R2 plus R3 and R4. We have add we have added here four resistance at the initial time. Then by this addition of resistance we can reduce, or with the help of addition of that these four resistance, we can reduce the initial high current to a limited, or say permissible value, and a field current will flow through the NVC coil. And what is the full form of NVC coil, Khushbu?
No voltage coil.
No voltage coil. Good. So after that, if we put the lever in two position, then we can see that the armature current, or say the resistance through the armature path reduced to R2 plus R3 plus R4. So at position 2, the value of armature current is V minus, say, EB1 by RA plus R2 plus R3 plus R4, because when the current is flowing through armature and as well as field, so a torque is produced. Because what is the equation of torque? What is the equation of torque, Ayush? What is the equation of torque, Ayush?
Sir, K and phi.
N phi. K n phi. This is the equation of torque. Khushbu, tell me what is the equation of torque? T is equal to
Sir, IF
K
and IF.
n if. No, this is basically the equation.
Sir,
T is
K
equal to
phi IA, sir.
phi Ia. Good. This is the equation. In a year. So if we flow a current through the field and as well as armature, then a torque is produced. So if a torque is produced on armature, what will happen? It will it will Ayush, if torque is produced on armature, what will happen?
Sir, it will rotate the armature.
It will rotate the armature, and if there is value of rotation, so a back EMF will form, because the equation of back EMF is P phi NZ by 60A. So if there is N, so there should be some back EMF. So that's why the equation becomes, say, IA2, we write IA2 at the point 2, the value of armature current at the point 2, it is denoted by IA2. The equation is V minus EB1 by RA plus R2 plus R3 plus R4. So though we reduce the resistance, then the point 1, we reduced here the resistance, then the position 1, because in armature path now the resistance 1 is eliminated. So we can say we reduce the resistance, so the value of armature current will increase, and if the value of armature current will increase, then the torque is also more than the previous one. So the speed of that rotor, or say speed of the motor, will increase further, then the back EMF is also increase further. So similarly, if we put point 3, we reduce the resistance R1 and R2, and at that time the armature path resistance is Ra plus R2, sorry, R3 plus R4. And similarly, if we put the lever in 5 position, then at that time, what is the equation of armature current? If we put at the point 5, At that time, the value of armature current should be V minus Eb by Ra, because we eliminate all the additional resistance at point 5. See, at point 5 we eliminate all the resistance which are inserted at the time of starting. So 5 position is, say, the running position or run position of that motor. So gradually we in change the position of lever from 1 to 2, 3, 4, and 5. Finally we reach the point 5, and this is basically the running position of the motor. And at the point 5 there is no additional resistance in the path of armature, so the motor will running with its rated speed. And what is the function of a NBC coil? If there is no NBC coil and the position of the lever is 5, if at that time, if we release that lever, what will happen? The lever will goes from 5 position to off position due to this spring. Due to this spring, the lever goes from 5 position to off position if we release that lever. So we have to stuck that lever in 5 position when the motor will at running condition. So we have made a coil which name is NVC coil, which create a magnetic field when the machine will run. At the time of running, the or if we give the supply to the starter, then the NBC coil will produce a fluxes. Due to this flux it becomes a magnet. This becomes an electromagnet. So so if we put the lever in fifth position or 5 position, then due to this NBC coil, the lever stuck at 5 position. After releasing the lever, so anyhow, if the power cut happen, then the NBC coil get demagnetized and the lever goes to off position. Have you understand? Ayush, have you understood? Sorry, Ayush, have you
Yes, sir.
understood? Khushbu,
Yes, sir.
and see the configuration or see the configuration of that lever. What will happen, or what we do actually here? In all the current or the total current is flowing through the OLC coil. So when suppose the motor will at overload, suppose at overload, that means the value of armature is greater than the value of armature full load current. If the motor becomes overloaded, what will happen, Ayush? Ayush, if the motor becomes overloaded, what will happen?
So it will keep it into off position.
No, no, no. But just tell me, if the motor gets overloaded, what will happen in armature current?
So it may get burned, sir. May
It
get
may
damage.
burn. That means I just want to listen that the current at that time, or say current at overload, overloaded is greater than the full load current. जब ओवरलोडेड होगा तब करंट का क्या होगा, आर्मेचर करंट का वैल्यू वो फुल लोड करंट से ज्यादा होगा.
Yes, sir.
That means at that time all the current will flow from that OLC coil up to full load current. This plunger is not attracted by OLC coil. Though the current is flowing through OLC coil, the OLC coil also becomes a electromagnet, and up to the full load current, the OLC cannot attract that plunger. And when a current is flowing through the OLC greater than the full load current. Suppose a overloaded current will flow through the OLC. Then OLC can attract this plunger, and if the plunger is connected by or the plunger is attracted by OLC, what will happen? And here or say at that point what will happen? उस दो पॉइंट में क्या होगा आयुष, खुशबू, देखिए गौर से. If the plunger is attracted by OLC coil, ये दो पॉइंट क्या होगा, कैसा दिख रहा है ये दो पॉइंट?
सर शॉर्ट हो जाएगा सर.
हाँ, मान लीजिए एक प्लंजर है ऐसा, ऐसा है. हम अगर इसे ऊपर की तरह प्रेस कर देंगे तो क्या होगा, ये दो पॉइंट क्या होगा, ये दो पॉइंट क्या होगा बोलिए खुशबू. Tell me what will happen if we push that plunger in upward direction. What will happen? खुशबू,
Yes, sir.
क्या होगा, ये अगर हम इस प्लंजर को ऊपर की तरह खींचेंगे तो ये दो पॉइंट में क्या होगा?
सर नहीं समझ आ.
नहीं समझ में आया. अच्छा आयुष,
सर वो शॉर्ट हो जाएगा सर, वो टच हो
दैट
जाएगा तो.
मीन्स these two point get contact, ये दो पॉइंट कांटेक्ट में आ जाएगा. ये प्लंजर एक्चुअली होता है किसका, ये कंडक्टिंग मटेरियल का बना होता है. द प्लंजर is made by a conducting material. So if we push that plunger towards this point, so what will happen, क्या होगा ये ऊपर की तरह जाएगा और ये कांटेक्ट में आ जाएगा ना, ऐसे करके चला जाएगा, ये कांटेक्ट हो जाएगा. दैट मीन इफ वी push that plunger upward, these two point get contacts. If these two point get contacts, what will happen? Then see that the current will flow through that point or that path, because there is a NVC coil. Suppose if we make a coil, suppose we make a coil here and we give a different path where this is basically only wire. Suppose current will coming or coming from that point, that path, and after that the current, see that there is two paths. In one path there is a coil and another path it is only straight wire current will prefer which path? Current will prefer which path? Ayush?
So straight
The
straight wise,
straight
sir.
path. Yes, good. Because the resistance of that path is near equal to 0, and there's some resistance on that coil. Due to that coil, there's some resistance, so current prefer this least resistance path. That means here, if the field current is coming up to here, after that it will see there is two path. If the plunger is not contacting with these 2 point, then there is open, so current will prefer the least resistance part at that time through the NBC, because there is a open circuit. So the resistance of that point, that's in between these 2 point, is very high, so the current will prefer that path. That means through the NBC coil. And if these two contact are make, so then at that time the current will prefer this path, and no current will flow through the NBC coil. So what will happen? If there is no current through the NBC coil, what will happen? Khushbu? Khushbu? Can you tell me what will happen if there is no current through NBC coil? Previously, when the motor will running at or say running condition, at the running condition, a current will flow through the NBC coil. That's why due to the current, the NBC coil gets energized and it becomes an electromagnet, and it hold the lever at fifth position. And if overloaded happen, so overloaded current will flow through the OLC. That's why this plunger is attracted by OLC, and due to the attraction, these 2 points get contact. So the current will prefer that path, and no current will flow to the NBC coil. So what will happen at that time?
So the handle will be in off position.
Yes, goes. Due to there is no current in NBC coil, so NBC coil get de-energized. That means there is no magnetic field. So if there is no magnetic field, then due to the spring, due to the spring, this lever goes to off position, and motor will protect from burning. Motor will protect from burning. That means if there is overloaded happen, then the motor should be protected. Otherwise, motor will get burned. So there is a NBC coil and there is a OLC coil. Due to this OLC coil, a contact will make in between A and A. Due to this contact, there is no current flowing through the NBC coil, and the NBC coil get de-energized, and the lever goes to off position, and there is no power to the motor, or there is no voltage or current to the motor we are supplying at that time. That's why the motor gets safe, or do not get burned due to this protection system. So by this method we can protect the motor from overload. आयुष समझ में आया दीपक?
सर तो सर सारा करंट तो सर फील्ड कॉइल से पास कर जाएगा एट ओवरलोड.
नहीं, ओवरलोड में तो देखिए ना, दो तरफ से तो करंट जाएगा. The current divided into two paths, one from this path and another through this resistance. यहाँ से जाएगा. कौन सा करंट का वैल्यू ज़्यादा होता है, आर्मेचर या फील्ड?
So armature.
So the armature current value is more than the field current, and the maximum current is flowing through the armature coil.
सो ओवरलोड के टाइम तो ऑफ रहेगा, तो आर्मेचर से तो कोई करंट ही नहीं जाएगा।
जब ओवरलोड होगा तब क्या होगा, पूरा करंट जा रहा था आर्मेचर से, फील्ड से जा रहा था, तो जो आर्मेचर करंट ही ज़्यादा बढ़ेगा जब ओवरलोडेड होगा, क्योंकि फील्ड करंट में तो कुछ नहीं होगा। वो जो करंट जब ओवरलोडेड होता है तब क्या होता है, आर्मेचर करंट इंक्रीज करता है, फील्ड करंट नहीं इंक्रीज करेगा। कौन सा करंट इंक्रीज करता है एट द टाइम ऑफ ओवरलोडिंग? Which current value has increased at the time of overload? Armature current or field current?
सो आर्मेचर।
Armature current. So इन बीसी से तो पूरा करंट नहीं जाएगा। करंट कहाँ से जाएगा, वो आर्मेचर से जाएगा, मतलब आर्मेचर जल सकता है, फील्ड में तो कुछ नहीं होगा।
सो जब प्लंजर कनेक्ट होगा
हम्म,
तब आईएफ और आर्मेचर करंट
हम्म।
वो कहाँ से पास करेगा सर?
देखिए,
वो तो सब पास नहीं करेगा ना सर आर्मेचर से, जब प्लंजर कनेक्ट हो जाएगा तो।
नहीं, प्लंजर जब कनेक्ट होगा तब तो आर्मेचर से जो करंट जा रहा था वो तो जा ही रहा है। जो फील्ड करंट पहले एनबीसी से जा रहा था, अब ये बाईपास होके जा रहा है। नॉर्मल कंडीशन में क्या हो रहा है, एक आर्मेचर करंट जा रहा है, एक फील्ड करंट जा रहा है थ्रू एनबीसी कॉइल। If overloaded happen, that means the value of armature current increase from previous one। वो आर्मेचर करंट का भी वैल्यू सिर्फ बढ़ेगा ना, फील्ड करंट का क्या वैल्यू, वैल्यू क्या इंक्रीज होता है?
नो सर।
तो मतलब ये जो आर्मेचर करंट का ये सिर्फ वैल्यू इंक्रीज होगा, फील्ड करंट का वैल्यू इंक्रीज नहीं होता ओवरलोडेड होने से। एक्चुअली ओवरलोड होगा तो कौन सा कॉइल जलेगा, आर्मेचर कॉइल या फील्ड कॉइल?
सर आर्मेचर चलना चाहिए।
आर्मेचर कॉइल ही जलेगा, क्योंकि वहां से ही ज्यादा करंट जाता है। तो जब ओवरलोडेड हुआ, लेकिन वो पूरा करंट जाएगा ओएलसी कॉइल से। कोई भी करंट इंक्रीज हुआ, वो इंक्रीज, जो इंक्रीज हो रहा है वो उसका इफेक्ट ओएलसी में आएगा, क्योंकि ओएलसी से पूरा करंट जा रहा है, जाके दो पार्ट हो गया। जब ओएलसी का वैल्यू, करंट का वैल्यू ज़्यादा होगा, तब ये प्लंजर को खींचेगा, तो तब ये दो पॉइंट कांटेक्ट हो जाएगा, ये पॉइंट कांटेक्ट हो जाएगा, तो फील्ड करंट और एनबीसी कॉइल से नहीं जाएगा, वो क्या करेगा, ये कांटेक्ट से फिर फील्ड में चला जाएगा। तो क्या होगा, तब ये एनबीसी कॉइल डीमैग्नेटाइज्ड हो जाएगा, वो और 5 पोजीशन पे लीवर को नहीं रख सकता है, वो स्प्रिंग उसे खींच के ऑफ पोजीशन में ले चला है। आया समझ में?
यस सर।
And if there is low voltage, suppose low voltage or no voltage, what will happen? If there is low voltage or no voltage, what will happen? Tell me, आयुष। तब ये एनबीसी कॉइल का हाल क्या होगा? If there is low voltage or no voltage,
सर तब
suppose
भी ऑफ
first
रहेगा।
first first consider
ऑफ
there is
रहेगा
no voltage, what will happen? If there is no voltage, that means there is no current flowing through the field coil and armature coil. At that time, the NVC coil get de-energized, and the lever position goes 5 to off, goes 5 to off position due to the spring. अभी लो वोल्टेज हुआ तो क्या होगा? लो वोल्टेज से क्या होगा बोलिए? तब इसका स्ट्रेंथ कैसा होगा? इनविसी कॉइल का जो मैग्नेट जो क्रिएट हुआ है, उसका स्ट्रेंथ क्या होगा? घटेगा कि
सर
सेम ही रहेगा?
घटेगा।
अगर स्ट्रेंथ घट गया तो ये 5 पोजीशन में लीवर को रख सकता है कि स्प्रिंग इसे खींच के ऑफ पोजीशन में ले चला जाएगा?
सो 5 पोजीशन पे नहीं रहेगा सर,
5
ऑफ पे आ
पोजीशन पे
जाएगा
नहीं
सर।
रहेगा, वो खींच के ऑफ पोजीशन में चला जाएगा ड्यू टू दैट स्प्रिंग। Due to that spring, if there is low voltage, the NBC coil cannot keep the lever in 5 position and spring will take it to off position. And this
सर लो
position is,
वोल्टेज में मोटर धीरे नहीं घूमेगा?
हाँ धीरे घूमेगा तो बैक ईएमएफ ज़्यादा हो जाएगा ना। ज़्यादा ही होगा कि कम होगा? जब लो वोल्टेज लो हो जाएगा तब स्पीड का क्या होगा? स्पीड कम जाएगा,
हाँ।
because speed will get reduced. So back EMF, the value of back EMF also reduced. आर्मेचर करंट
यस
का
सर।
हल क्या होगा? आर्मेचर करंट क्या होगा?
तो वो भी घट जाएगा।
आर्मेचर करंट घट जाएगा कि बढ़ जाएगा? ये वोल्टेज भी घट रहा है, ये भी घट रहा है। एक्चुअली वो कॉम्पिटिटिव में हम अगर देखेंगे तो आर्मेचर करंट का वैल्यू ज़्यादा हो जाता है, तब आर्मेचर बार्न हो सकता है। इसीलिए हम क्या करेंगे? प्रोटेक्शन देंगे फ्रॉम लो वोल्टेज। कंपैरेटिव में देखते हैं कि आर्मेचर करंट इंक्रीज कर जाता है जब लो वोल्टेज होता है। आया समझ में दीपक?
हाँ सर।
That means when the low voltage, if there is low voltage in power supply, then we can see there is increment in armature current. So we have to protect the motor from low voltage also. So that's why we write the purpose of starter R to number one, it limits the initial high current, and number two, it protects from overcurrent. And Ayush, tell me the second point. Ayush, audible?
Yes, sir.
So tell me what is the purpose of using starter? What is the purpose of using starter? हम ये starter क्यों यूज करते हैं बोलिए? किसको पता है?
Limit the initial high current or starting high current.
Yes, good. Next one.
Protect
So,
from overload and low voltage.
Protect from over current
And
and low voltage. अच्छा मान लीजिए अगर ये समझ में आ गया ना तो स्टार्टर कैसे काम करता है, कैसे प्रोटेक्शन देता है, ये समझ में आएगा ना? खुशबू, आयुष, दीपक, ये सब समझ में आ गया ना?
yes, sir.
Suppose we are performing the speed control method of, or say field control method of speed control method. That means what we have done, we are adding a resistance in path of field. हमने क्या किया, इस फील्ड पाथ में एक रेजिस्टेंस ऐड कर दिया. सो व्हाट विल हैपन, हम अगर फील्ड पाथ में एक रेजिस्टेंस ऐड करेंगे तो क्या होगा? इफ वी ऐड ए रेजिस्टेंस इन फील्ड पाथ, व्हाट विल हैपन इन फील्ड करंट?
तो कम जाएगा.
हम अगर मान लीजिए एक्सटर्नल रेजिस्टेंस है, हम अगर इसे इंक्रीज करेंगे, इफ वी इंक्रीज द एक्सटर्नल रेजिस्टेंस वैल्यू, व्हाट विल हैपन? फील्ड करंट का क्या
Current
होगा?
decreases.
फील्ड करंट का क्या होगा? तो घटेगा. The field current will decreases, and the value, if the value of field current will decreases, what will happen in NBC? What will happen in NBC? The magnetic strength of NBC coil also reduced. Ayush,
Yes, sir.
if we decrease the value of field current, then the magnetic strength of NBC coil also reduced. So after certain value of field current, NBC coil cannot keep the lever in fifth position or fifth position. Have you understood? आयुष, दीपक, मनीष, खुशबू, देखो समझ में आया कि नहीं? समझ में आया?
Yes, sir.
So by, or say with the help of 3-point starter, or if we use 3-point starter, we cannot perform the field control method of speed control in wide range. We cannot perform the field control method of speed control when we using a 3-point starter. वाइड रेंज में हम नहीं कर सकते, थोड़ा बहुत कर सकते हैं, लेकिन we cannot perform the speed control method, or say field control method or speed control method in wide range. ये समझ में आया कि नहीं? देखो दिस इज ए ड्रॉबैक ऑफ 3 पॉइंट स्टार्टर. आया समझ में?
Yes, sir.
So Manish, tell me the drawbacks of 3 point starter. Manish. Samsad. Samsad. Praveen. Yes. Anyone? Tell me the drawbacks of 3 point starter.
सर स्पीड कंट्रोल पे प्रॉब्लम होगा सर, क्योंकि एनवीसी कॉल में फिर ज़्यादा करंट रहेगा नहीं,
मतलब
जिसके
हम वाइड रेंज में फील्ड कंट्रोल करके स्पीड कंट्रोल नहीं कर सकते.
यस सर.
We cannot perform the field control method of speed control in wide range. Okay, that's all for today. Have you any question regarding this?
सर
हाँ बोलो.
सर एक बुक में देखे थे ओएलसी का मतलब ओएलआर भी लिखा था, तो उसका क्या मतलब होता है?
क्या था?
ओएलसी को ओवरलोड रिले लिखा हुआ था.
तो मतलब वो कॉइल से नहीं एक रिले लगा दिया.
तो रिले क्या होता है सर?
रिले भी एक कॉइल की तरह ही होता है. वो ये जो सिस्टम देखिए यहाँ पर क्या है, सेपरेट है. ये जो सिस्टम देखिए, ये प्लंजर बाहर की तरह है, ये ओएलसी कॉइल इधर है. वो एक रिले क्या होगा, उसके अंदर ही ये सब अरेंजमेंट होगा. मान लीजिए एक बॉक्स की तरह है, उसके अंदर ही सब रहेगा. एक कॉइल रहेगा, यहाँ पर प्लंजर होगा, सब
अच्छा.
उसका अंदर ही रहेगा.
ठीक है सर.
वो पावर सिस्टम में आप लोग सब रिले पढ़ेंगे जब, शायद आपको थर्ड ईयर में वो मिलेगा पावर सिस्टम. उसमें आप रिले पढ़ेंगे. बहुत टाइप का रिले होता है, उससे भी हम यूज करते हैं. कभी कभी जब ज़्यादा मोटर का रेटिंग ज़्यादा होता है तब हम वो रिले यूज करते हैं. लेकिन ये नॉर्मल जो यूज होता है उसमें रिले नहीं, ऐसे ही ओएलसी कॉइल देते हैं. और कोई क्वेश्चन? So I'll take the attendance. Deepak,
यस सर.
Ayush,
यस सर.
Khushbu,
Present, sir.
Danish,
यस सर.
Jishan,
यस सर.
Manish, Praveen,
प्रेजेंट सर.
Samsad,
यस सर.
Yes,
प्रेजेंट सर.
Asghar.
यस सर.
Okay, you may leave.